Hi everyone, this is Fateh Lohar, Assistant Professor, Department of Electronics and Communications, Engineering College, Alawad. E-lecture is prepared for RTU syllabus, antenna and wave propagations for 6th semester students. As per previous lectures, we have discussed microstrip antennas, okay, and discussed the basic characteristic of the antennas, and also discussed the disadvantage and advantage of the antennas. Okay, practical representation of the antennas and type of the structures. Okay, so today we discuss about the antenna feed methods. Okay, how to power we feed in antenna. Okay, so there are the different methods. Major method is four type of methods they generally use. First is microstrip lines, second is coaxial probe, third is aperture coupling, and four is proximate coupling. These four type of the feeding methods. Okay, so first we discuss the microstrip line feed. Basically, the microstrip lines basically simple uh, strip lines. It directly contact to the antenna. Okay, so that means we can see this is the conducting line to directly contact to the antenna. The width of the line is compared to the patch is very less. Okay, and the width of the microstrip line depend on the impedance. So we can vary the characteristic impedance according to the width variations of the line, and the length of the line. This is the width or this is the length of the line. Length of the line generally we taken lambda by 4. Okay, so this is also very simple for fabrication and for fabrication purpose. The microstrip line is very easy. Okay, and also we can match the antenna impedance easily by varying the length width. But the microstrip line have the two type of the disadvantages. First is spurious field radiations, second is surface wave radiations. Both are the undesirable radiations. So by microstrip field line, both type of the radiations are generated and practically designed limit the bandwidth approximately 2 to 5 percentage. This is the equivalent circuit of the microstrip line. Inductor in series and resistor, capacitor and inductor in parallel. Okay, this is the practical model of the microstrip line. This is the design of the basic antenna with the microstrip line. This is the electric field distribution with the microstrip lines and gain of the antennas. Okay, next we discuss the profits. To reduce the disadvantage in microstrip lines like the spurious wave and surface waves, so we use the probe feed या coaxial feed. Okay, you can see this is the simple circular page antenna, or you can see conducting antenna. The antenna the power supply by the coaxial piece. They are the one coaxial connector. Okay, and inside you can see that this is the inner conductor. So we can power feed through this inner connector to the page. In middle part is the substrate material. Okay, so the antenna impedance we can vary from the changing the diameter of inner connectors and outer uh, dielectric material. Okay, right. So the coaxial feed is easy to fabricate and match and has low space radiations. However, it also has narrow bandwidth. It is more difficult to model, especially for thick substrate. It's only for thick substrate. Okay. So now we discuss the practical model. This practical representation of feed. You can see in this case we use the rectangle antenna. This is the rectangle antenna page. Yeah, this is the inner conductor. Okay. Or this is the outer conductor. In between the inner and outer conductor, there is a Teflon materials. Work as a dielectric material basically. This is ground. Okay. So we feed the power from the in this port. We apply the power through the SMA conductor. Generally, the impedance of the conductor feed line is 50 ohms. Basically, a lot of the SMA connector available in market in 50 ohms. So we design the coaxial piece approximate 50 ohms characteristic impedance. So for matching purpose, the impedance we can vary the location of the feed locations in the page antenna. If the impedance of the feed line and impedance of the page match, both are the 50 ohms, then is antenna is matched and the maximum power is transferred to the page, and replacement coefficient also minimum. Okay. So you can also see the electric field distribution or a power distribution. This is the electric field distribution of the page, ground plane and feed line. Okay. This is the gain of the antenna. This is also conducting feed lines. Now we discuss the aperture coupling. In previous two type feeding methods, aperture feeding, probe feeding or coaxial microstrip feedings, both are the contacting feed line. Basically, they directly contact to the page antenna. So these are the aperture coupled feeds are the non-contact feed method. Basically, the power is coupled, not direct contact. So you can see the aperture couplings of the antenna. You can see the first is page, second part is ground structures, third part is second ground substrate material or in beneath of the ground strip lines. Okay, the power is coupling from strip line to the ground and ground to the page. So there is no direct metallic contact. So power is coupled to ground strip line to the ground and ground to the page. In ground there are the aperture. Basically aperture is a simple type of the slot. Due to the aperture the power is coupled to the page. Okay. This also have the minimum cross polarization, means not have surface wave and not have a spurious radiations. So you can see that this is the equivalent circuit of the aperture feed line. Okay. And so aperture is in this case we use the two type of dielectric material. Okay, ER1, ER2. So this is the practical representation of the aperture feed. You can see in beneath this is the feed line. This is a simple microstrip line. Okay, so also length and width depend on the impedance. Okay, so we can change the impedance according to changing the width. And middle part is the above the field line there is a substrate 2, and above the substrate 2 there is a ground plane with the aperture, this type of slot. And above the aperture, above the ground plane, there are another substrate material 1, and then patch. Okay, this is the radiation pattern of the aperture feed antenna, and this is the electric field distribution of the aperture field lines. Another feed method is approximate couple feed line. Is also a non-contact feed method, and also the power is coupled by the power is not directly contact. The energy is not directly contact to the pitch. Basically, the power is through the coupling method. But the approximate coupling has the largest bandwidth as per the 30% approximate, and easy to model and has a spurious radiations. Its fabrication is somewhat more difficult. The length of feed stub and the width to line ratio of the page can be used to control the match. Okay, these are equivalent circuits of the approximate coupling. Practical representation of the approximate feed lines. This is the this is the ground plane. Above the ground plane, we use the substrate 2. Above the substrate 2, we use the strip lines. Okay, and above the strip line, we use the substrate, and above the substrate, we use the page. Okay, so this is the feed line. For the width of the feed line, we can vary the impedance, characteristic impedance of the line. Okay, so this is the distribution of the electric field, or this is the gain of the field line. So these 4 type of field line generally used for microstrip patch antenna. In next lecture, we discuss the type of the methods of analysis. Okay, what is the mathematical representation of the microstrip patch antenna, and type of the methods. Okay, so tomorrow we will discuss about or in next lecture we will discuss about the type of the method of analysis of patch antennas. Okay.